All right, so let's talk about scale drawings here. So here's how scale drawings work. I want you to do this with me. Let's say that you were going to design a building, and here's our building. It is a very nice, tall building. It's got windows. It's got a door, so you know it's a building. Okay, so let's say, for example, you measure this out, and from sorry, I'll give you a second to draw your beautiful building. It can look like mine. It can be fancier than mine, and it can be a squarish, whatever you want it to be. I draw all my buildings kind of the same, so. All right, and let's say the height of your drawing, okay, is 5 inches. The height of your drawing is 5 inches. Now here's your scale, okay? Your scale is for every 1 inch, it's actually equal to 20 feet in real life, okay? So 1 inch is equal to 20 feet. So the question is going to be simple. The question is going to be, how tall is the building in real life? Okay. How tall is the building in real life? Now, we've actually done this before. We're going to go all the way back to chapter 1. All the way back to chapter 1, solving proportions. Okay, we're going back to August and September here. Solving a proportion. So this is how we do this problem, okay? The first thing we're going to do is we're going to take this scale factor, 1 inch by 20 feet, and we're going to make it a ratio. 1 inch to 20 feet. And then we're going to set up a proportion. So this is going to equal, okay. Now, what information do we know? We know that this drawing is 5 inches. So we're going to put 5 inches on top. Now, why on top? Because we remember we match units, right? Inches on top, inches on top. Feet on bottom, feet on bottom. You guys kind of remember this, right? So I'm also going to think about this one is the small one, okay, over the big one. You can think of it that way. Now, what I don't know is the height in actuality, right? I don't know what the actual height is, so I'm going to put X. Okay, now hopefully this looks familiar, but we haven't done this in a while. So what I'm going to do is I'm going to cross multiply and solve, right? Cross multiply and solve. You guys remember that? Okay, so here we go. 1 times X is 1X, or just X, is equal to 20 times 5, which is 100. 100 what? Remember, we're missing this right here. We're missing feet, so this is going to be 100 feet. So X is equal to 100 feet. That look familiar? You guys remember doing that, proportions? Okay. So that's all you're doing in scale drawings is you're setting up with these proportions. I'm saying, hey, in my drawing, it's only 5 inches. How big is it in real life, right? And that makes sense because anytime you draw a piece of paper, if you draw a house on a piece of paper, it's not the size of the house, is it? Right? It's just a scale model of the bigger building, the bigger house. That makes sense? All right, so let's do another example here. Let's talk about your room. Let's do another little drawing here. Let's say that you have a room and we'll just say it's a nice rectangle. And what kind of things are in your room, right? What kind of things do you guys have? Look around. What kind of big furniture things do you guys have that are in your room? All right. So I'm guessing you guys have like a bed, right? So let's just make space here for your bed. What else do you guys have? A dresser. Oh, that's good. Maybe that's over here. All right. Ooh, a couch. Ooh, nice. Maybe I have a couch. Cool. We'll put that opposite of the bed here. Maybe you got a couch in there. What else do you have? Anyone have a TV in the room? Ooh, nice. TV in the room. Computer desk, right? Maybe a desk. Ooh, a fish tank. That's cool. Maybe the fish tank's right here near the bed. All right. I'm not gonna draw all the clothes and stuff that you guys have on the ground. Okay, all the random stuff that because you haven't cleaned up your room in 2 weeks. Okay, I'm not gonna draw that. But all right, so you get the idea. All right, so we have a room, and let's say that in our scale drawing, the width of our room or the length of our room is 1.5 inches, and the length is 2 inches in our drawing. So our scale factor here, or not scale factor, our scale is for every half inch, it's equal to 4 feet. Every half inch is equal to 4 feet. All right, can you tell me how long and how wide your room actually is? How long and how wide your room actually is? I'll give you guys a second to try that out, and then I'll start going over it um, here in just a second. So again, all you're doing is you're setting up a fraction, a proportion rather, and you're gonna just solve the proportion, kind of like we did way back in chapter 1. All right, I'm gonna start with the length since that one's the easier one that doesn't have the fraction. So this is my length here, and this is my width. Okay, so remember, first thing I'm gonna do is I'm gonna take this fraction. I'm gonna say, okay, 1/2 inches over 4 feet is equal to some amount of inches, 2 inches, over some amount of feet. I don't know what that is. Again, where did I get that 2 from? I got the 2 from right here. 2 inches, 2 inches. Okay, okay, let's do the math. Here we go. 1/2 times x is equal to 1/2 x. And 2 times 4 is equal to 8. Everyone with me so far? All right. Now, How do I solve this? Remember, if I have a fraction coefficient, I actually don't divide by 1/2. I'm going to multiply by the reciprocal, right? So I'm going to multiply by 2/1 on both sides. So I end up with 2 cancels, 1 cancel. I'm left with x here. And 8 times 2, which is 16. Yeah? Okay, can you guys do the width one? Let's set that one up. Let's help. Okay, so here's our length. So the actual size of the room is 16 feet. How about the width? Let's do this down underneath here. All right, so again, we're going to use the same scale factor, right? The same scale factor, or the same scale rather. 1/2 is equal to 4 feet. So let's set that up. Here we go. 1/2 inches is equal to 4 feet. Okay, over 4 feet is equal to, let's use our new number here, 1 1/2 inches over x, something we don't know. Yeah? All right, here we go. Let's multiply. 1/2 inches times x is equal to 1/2 x. Okay, now 1 1/2 times 1 times 4. 1 1/2 inches times 4. Anyone know what that is? Okay. Or you can think of it 3/2 times 4. Let's do that over here on the side real quick. So 3/2 times 4. That cancels. That becomes a 2. So we end up with 6. All right. So 6. 1/2 equals 6. All right. So what's my final answer? X equals what? We're going to multiply by the reciprocal here. 2/1. And cancel, 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 cancel. X is equal to 6 times 2, which is 12. Okay. Now, there are easier ways to do it. Yeah, that's a good point, right? I'm like, Mr. Long, this looks all crazy and stuff. Okay, this is just what it works every time. Now, if you can logic it through and figure out an easier way and think, well, you know what, Mr. Leong, in 1 1/2, there are 3 1/2 inches. So I can just multiply 3 times 4, easy. Or in 2 inches, there's 4 1/2 inches. So I can just say that times 4 and get 16, no problem, okay? Um, Basically, you're just figuring out a way to blow up the picture or make the picture smaller sometimes using these ratios, okay? And the ratios, again, are really, it's simple. It's stuff we've done before. We just haven't done it in a while, right? And that's what we need to do. So the biggest thing is being able to set up the proportion. I believe that if you can set up the proportion, then you can solve the proportion. So the proportion I'm talking about is here. Again, use that 1/2 inch and 4 feet to start off your proportion. And then set it up and multiply. Okay. Um, so you're doing that again. This one might be an easier example to look at. Example A. Again, where did I get this 1 inch to 20 feet? Becomes my proportion. 1 inch to 20 feet. And then you figure out just you're missing something. And that's how you do that. All right.